In question 1, we've got 7 red, 3 blue, and 2 yellow counters. Now Gina selects a counter at random and keeps it. If the counter is yellow, she does not select any more counters, but if it's not yellow, then she randomly selects a second counter from the bag, and we need to complete the tree diagram. So we've got a total of 7 plus 3 plus 2, 12 counters, 7 of which are red, 3 of them are blue, so the probability of a blue is 3 out of 12, and 2 out of 12 is yellow. Now, if the first counter is red, this means I'm left with a total of 6 red counters out of a total of 11, so this is 6 over 11. I still have 3 blue counters out of 11 and 2 yellow counters. However, if the first counter was blue, then I'm left with 7 red counters out of 11, 2 out of 11 being blue, and 2 out of 11 being yellow. Notice that the sum of the probabilities for each set of branches is 1, so that everything looks okay. That was part A, the tree diagram. In part B, it is given that Gina has selected the yellow counter, and we need to find the probability that she has 2 counters. So this is an example of conditional probability. We know for sure that she selected a yellow counter, so it could be a red and a yellow, a blue and a yellow, or a yellow. This is known to have happened for sure, and we're wondering what's the probability of 2 counters, which means the red yellow or the blue yellow scenario. So I'm gonna have in the numerator the sum of these 2 probabilities, and in the denominator what I know for sure to have happened, which is the 3 scenario here. So this gives me in the numerator 7 over 12 times 2 over 11 plus the 3 over 12 times the 2 over 11, and in the denominator we've got the 7 over 12 times 2 over 11 plus the 3 over 12 times the 2 over 11 plus the 2 over 12, which is the probability of picking a yellow counter the first time you draw a counter. Put this on the calculator, you get an answer of 10 over 21. In question 2, we've got a Venn diagram with events A, B, and C. We are told that A and C are independent and the probability of A is 0.65, and we need to state which 2 of the events A, B, C are mutually exclusive. Well, mutually exclusive means they are appearing as disjoint circles on my Venn diagram, so they have nothing in common, and this is B with C, and therefore we conclude that B and C are mutually exclusive. In part B, we are told to find the value of R and the value of S, and I will be using the fact that A and C are independent, which simply means that the probability of A intersection C is the probability of A times the probability of C. Well, A intersection C is this region here, the common region between events A and C, which is 0.13. The probability of A has been given to be 0.65, and the probability of C is the R plus the 0.13, so R plus 0.13 in brackets. If I divide by 0.65, I get 0.2 is equal to R plus 0.13, which means that R is 0.07. Now to proceed and find the value of S, I will simply say that the sum of the probabilities should be 1. We already know that the probability of A is 0.65. We have established that R is 0.07, so I can simply say that 0.65 plus the R, which is 0.07, plus the S is 1, so 0.72 plus S is 1, which means that S is 0.28. We are then told that the events A intersection C dash and B union C are also independent, and we need to determine the value of P and the value of Q, giving our answers as fractions. Well, let's start by writing on our Venn diagram what we have already found from part B. R is 0.07 and S is 0.28. Now B union C means B or C or both, so this is what I've shaded here in blue, and A intersection C dash means I'm in A but not in C, which is what I've shaded here in yellow. Now I could start by adding everything up, so we've got that P plus Q plus 0.13 plus the 0.07 plus the 0.28 is equal to 1. This takes me to P plus Q plus 0.48 is equal to 1, and we therefore conclude that P plus Q is 0.52. I will then use the fact that A intersection C dash and B union C are independent, which means that the probability of their intersection is simply the product of the individual probabilities. Now the intersection of the yellow with the blue is simply this part here, which is Q, and therefore the left-hand side of this equation is Q. The A intersection C dash is simply P plus Q, and the B union C is Q plus 0.13 plus 0.07. Now we already know that P plus Q is 0.52, so this will go here. So I've got Q is 0.52 brackets Q plus 0.2. I will further expand this to give me that Q is 0.52 Q plus 0.104, leading to 0.48 Q is equal to 0.104, and therefore we conclude that Q is 13/60. Remember, we have to give P and Q as exact fractions. I will now proceed in finding P, and I will simply say that P plus Q, which was found to be 13/60, is equal to 0.52, and therefore this leads to P being 91/300. In question 3, we've got the lengths L centimeters of 100 carrots summarized in the grouped frequency table below. We are given the dimensions of the 5 to 8 class, and we are asked to find the width and height of the 15 to 20 class. I will start by drawing a table. We've got the 5 to 8 class with a frequency of 5 and a class width of 3, because this class spans from 5 to 8, so 3 units in width, whereas the 15 to 20 has a frequency of 30 and a class width of 5. The frequency density is the frequency divided by the class width, so 5/3 and 30/5, which is equal to 6. And for the width, I would say that 3 units in width require 1.5 centimeters on the histogram, so 3 corresponds to 1.5 centimeters, 5 corresponds to x centimeters, so x is 5 times 1.5/3, which turns out to be 2.5, whereas for the height, I'm looking at the frequency densities, so a frequency density of 5/3 needed a centimeter in height to be represented, so 6 will require y centimeters, so y is 6 times 1/5/3, which is equal to 3.6 centimeters, and therefore we conclude that the width of this bar is going to be 2.5 centimeters, whereas the height, the frequency density, it's going to be 3.6 centimeters. We are then asked to use linear interpolation to estimate the median length, so I will first go back to my frequency table and fill in next to the frequencies the cumulative frequency, which means that I've got 5, then 5 plus 13 is 18, plus 16 is 34, plus 25 is 59, plus 30 is 89, plus 11 is the 100, which is the total that was given in the question. Now for the median, the middle value, I will be doing 100/2, which is 50, and therefore I conclude that the median value, the median length, is in this class. So we've got 100 divided by 2 is equal to 50, and I will be interpolating in the 12 to 15 class. Now to do this, I quickly draw a diagram. So I want to go from 12 to 15, somewhere along the way it's the median, and below I put the cumulative frequencies. I have 34 observations up to 12, 59 observations up to 15. I want to interpolate the 50th observation, and again I'll be using ratio and proportion. I will be doing the small gap over the small gap is equal to the big gap over the big gap, which means I can write m minus 12 over 50 minus 34 is equal to 15 minus 12 over 59 minus 34. This leads to m minus 12 over 16 is equal to 3 over 25. I can cross multiply to get m minus 12 is 1.92, and therefore we conclude that the median m is 13.92 centimeters. In part C, we are asked to estimate the mean length and the standard deviation of the lengths. Now, to do this, I'll be using the class midpoints provided in the table together with the frequencies to calculate the sum of fx, which simply means I'll be doing 5 times 6.5 plus 13 times 9 plus dot 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 up to 11 times 24, which gives an answer of 1,452. And I will also be calculating the sum of fx squared, which is 5 times 6.5 squared plus 13 times 9 squared plus dot 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 plus 11 times 24 squared. And this gives an answer of 23,280. Well, to find the mean, I will simply do the sigma fx over sigma f, which in our case is 1,452 divided by 100, which is the total number of observations, which gives me 14.52 centimeters. And for the standard deviation, I've got the formula sigma fx squared over sigma f minus the sigma fx over sigma f all squared and all square root. So this is going to be 23,280 over 100 minus the 1,452 over 100 all squared and all square root. Put everything on the calculator. You get an answer of 4.69 centimeters, correct to 3 significant figures. In part D, we are told that the supermarket will only be buying carrots with the lengths between 9 and 22 centimeters, and we need to estimate the proportion of carrots that this supermarket will buy. So between 9 and 22, we surely have these 16, these 25, and these 30. But we also have got exactly half of these 13 because the 9 is halfway between the 8 and the 10. And for 22, we can see that it's 2/8 of the interval. So I'm going to take 2/8 of 11. So we've got a half times 13. We've got the 16, the 25, the 30, plus 2/8 of 11. And this gives an answer of 80.25. Remember, we've got a total of 100 carrots, so the proportion is 80.25 divided by 100, which gives an answer of 0.8025. We are then told that any carrots that the supermarket does not buy are sold as animal feed. So those carrots sold to the supermarket give me a profit of 2.2 pence. I make a profit of 0.8 pence through each carrot longer than 22 centimeters, and I'm actually making a loss of 1.2 pence for carrots shorter than 9 centimeters, and I need to find an estimate for the mean profit per carrot. So let's start by finding the probability that a carrot has a length of less than 9. Well, if I go back to my table for a moment, less than 9 is surely this 5, and then half of this 13. So I've got 5 plus a half times 13. I will divide this by 100, the total number of carrots. To turn this into a probability, it's 0.115. And the probability of L greater than 22, well, if I go back to the table once more, greater than 22 means I've got 6 out of 8 times 11. So divide that by 100 to get the probability that the length is greater than 22. So 6 out of 8 times 11 divided by 100 gives an answer of 0.0825, which means I can proceed in drawing a table. I've got the profit and the different possibilities. So I make a profit of minus 1.2 pence, so a loss actually if the carrot is less than 9 centimeters. We make a profit of 2.2 pence for carrots between 9 and 22 centimeters in length, and a profit of 0.8 pence for carrots longer than 22 centimeters, with probabilities of 0.115, 0.8025, and 0.0825 respectively. Remember, we're trying to determine the expected profit, so I will simply be multiplying the profit by the associated probability. So it's going to be minus 1.2 times 0.115 plus 2.2 times 0.8025 plus 0.8 times 0.0825. Plugging everything on the calculator gives me 1.6935 pence. Well, the examiner here is accepting anything that rounds to 1.7 pence. In question 3, we are told that the weights of letters W grams have a normal distribution with a mean of 165 grams and a standard deviation of 35 grams. And we need to estimate the proportion of letters that weigh less than 120 grams. So let me start by writing down the distribution. It's a normal with mean mu 165 and variance sigma squared 35 squared. We're trying to determine the probability of W being less than 120, and I will be using standardization. So it's the probability of Z less than 120 minus the 165 over the 35. Remember, we are subtracting the mean, dividing by the standard deviation. This gives me the probability of Z less than minus 1.29, which can be written as 1 minus the probability of Z less than 1.29. And I can go to the table of values provided in the formula booklet. For 1.29, I see the value of 0.9015. And therefore, this is simply 1 minus 0.9015, which gives an answer of 0.0985. We are then told that the letters are split into 3 categories: heavy, medium, and light, with a third of the letters in each category, and we need to find the weight limits that determine the middle category, the medium letters. So it makes sense to start by drawing a bell-shaped curve centered at the mean of 165, while I'm trying to determine the limit, which I will call L1 and L2, such that we've got a third in each of these classes. So a third, and a third. So from this, we can see that the probability of the weight W being less than L2 should be equal to 2/3, which is all of this area here. And this can be written as 0.6667. So I will standardize once more. So it's the probability of Z less than L2 minus the mu of 165 divided by 35, which was the standard deviation, and this is equal to 0.6667. So going into the table of values once more, I'm looking into the probabilities and I want to find the value that's closest to 0.6667, and it's 0.43, which means that L2 minus 165 over 35 should be equal to 0.43. Well, I can cross multiply to get L2 minus 165 is equal to 15.05, and therefore L2 is 180.05. Now to find L1, I could follow a similar approach that we did for L2, or I could simply employ symmetry, because the midpoint of L1 and L2 should be the 165. So I will simply say that by symmetry, we've got that L1 plus L2 over 2 is equal to 165, which leads to L1 plus the 180.05 is 330. I cross multiplied, leading to L1 is 149.95. We therefore conclude that the medium letters satisfy 149.95 being the lower limit and 180.05 being the upper limit. The mark scheme here is accepting anything that rounds to 150 and 180 respectively. We are then told that a heavy letter is chosen at random, and we need to find the probability that this letter weighs less than 200 grams. Once more, I will start by drawing my bell-shaped curve. I know for sure that I'm beyond L2, I'm a heavy letter, and we need to determine the probability that we are less than 200. So we need to find the shaded region here divided by what we know for sure to have happened, which is the probability of being a heavy letter. In other words, we want the probability that we're between 180.05 and 200 divided by the probability of being greater than 180.05. Now I will start by splitting the double probability in the numerator as the probability of W being less than 200 minus the probability of W being less than 180.05. In the denominator, the probability that I am greater than 180.05 is simply a third, so the bell-shaped curve is handy here to determine some of the probabilities. Now for the probability of W being less than 200, I will standardize, taking me to the probability of Z being less than 200 minus 165 over 35. The probability now of being less than 180.05 is all of this, so it's just 2/3, so minus 2/3 over the third. This takes me to the probability of Z being less than 1 minus 2/3 over a third, so I'll have to go back to the normal distribution table to extract the probability of Z being less than 1. So looking at the table, this gives me a probability of 0.8413, and therefore this is 0.8413 minus 2/3 over a third, which gives an answer of 0.5239. Finally, we are told that Chris chooses a random sample of 3 letters, and we need to find the probability that there is 1 letter in each of the 3 categories. Well, we could start by listing all the possibilities. So we could have a light, a medium, or heavy letter, or light, heavy, and then medium. Or we start with a medium, then light, then heavy, or medium, heavy, light. And finally, it's the heavy, light, medium, and heavy, medium, light. We've got a total of 6 combinations, and each of these combinations has a probability of a third times a third times a third of appearing, because the probabilities associated with each of the 3 classes are a third. So plug this on the calculator, get an answer of 2/9. In question 5, we've got the discrete random variable x with the following probability distribution. We are additionally told that the expectation of x is 0.5, and we are asked to find the value of a. Well, we know that the expectation of x is found by multiplying the values for x together with the associated probabilities and adding up all the pairs. So it's going to be minus 2a plus negative 1b plus 0c plus 1b plus 4a. This gives an answer of 2a, which is equal to 0.5 as given by the question, and therefore we conclude that a is 0.25. We are then told that the variance of x is 5.01, and we need to determine the value of b and the value of c. Well, I will start by saying that the sum of the probabilities should be 1. That will give you an equation involving b and c. So we've got that a plus b plus c plus b plus a is equal to 1, which means that 2a plus 2b plus c is equal to 1, where we already know that 2a is equal to a half, so we've got a half plus 2b plus c is equal to 1, and therefore 2b plus c is equal to a half. I will then proceed in finding the expectation of x squared, which is simply squaring the x values and multiplying by the associated probability. So that's going to give you minus 2 squared times a plus negative 1 squared times b plus 0 squared times c plus 1 squared times b plus 4 squared times a, which gives 4a plus b plus 16a, and I end up with 20a plus 2b. Well, we know that a is 0.25, so this is 20 times 0.25 plus 2b, and therefore the expectation of x squared is simply 5 plus 2b. Now, to find the variance of x, we've got the formula that says that the variance of x is the expectation of x squared minus the square of the expectation. So we've got that the variance of x is 5.01. The expectation of x squared is 5 plus 2b, and the expectation of x is a half, so minus a half squared. This leads to 5.01 is equal to 4.75 plus 2b, which means that 0.26 is equal to 2b, and therefore get that b is 0.13, and I can easily proceed in substituting b to be 0.13 here to find the value of c. So we've got 2 times the 0.13 plus C is equal to 0.5, which leads to 0.26 plus C is 0.5, and therefore C turns out to be 0.24. In part C, we've got a new random variable y defined to be 5 minus 8x, and we need to find its expectation and variance. So for the expectation of y, this is going to be the expectation of 5 minus 8x, which is simply going to be 5 minus 8 times the expectation of x, which is 5 minus 8 times a half, which turns out to be 1. For the variance of y, we've got the variance of 5 minus 8x. We know that anything that we add or subtract does not affect the variance, but anything that we multiply with will be taken out, factor out, and squared. So this is going to give me minus 8 squared var x. This is 64 times the variance of x, which is known to be 5.01, and therefore we get an answer of 320.64. In part D, we are asked to find the probability that 4x squared is greater than y. So we're dealing with x and y together in this probabilistic statement. I will start by writing y as 5 minus 8x. So this is probability of 4x squared greater than 5 minus 8x. I will be collecting everything on the left-hand side to get the probability of 4x squared plus 8x minus 5 being greater than 0. I will factorize the quadratic expression in x to give me the probability of 2x minus 1 times 2x plus 5 being greater than 0. And we've got critical values by setting each of the brackets to be equal to 0. So for the first one, we have 2x minus 1 is 0, which means that 2x is 1 and therefore x is a half. And for the second one, we've got 2x plus 5 is 0, which means that 2x is negative 5 and x is minus 5 over 2. Now to proceed, I draw my parabola. I've got my critical values at minus 5 over 2.5. I can see that I go plus, minus, plus, and notice that we want to be greater than 0. I want the plus region, which are the tails, the one on the left and the one on the right. So the probability required is simply the probability that x is less than minus 5 over 2, plus the probability of x being greater than a half. And if I quickly recall the table of values for the probability distribution for x, we can see that if we want to be less than minus 5 over 2 or greater than a half, this simply means that we can be 1 or 4 only. So that's going to be 0.13 plus 0.25, which gives an answer of 0.38. Alternatively, we could have avoided totally the process of solving a quadratic inequality, and I would simply add two rows here, the 4x squared and the y, which is 8 minus 5x. And depending on the values of x, I will find the corresponding values for 4x squared and y. So these turn out to be 16, 4, 0, 4, and 64 for 4x squared, and for y, we've got 18, we've got 13, we've got 8, we've got 3, and negative 12. Remember, we're trying to solve 4x squared being greater than y, and we can see that this is only satisfied here and here because 4 is greater than 3 and 64 is greater than negative 12. So these will only happen with probability of 0.13 and 0.25. And therefore we can easily conclude that the probability of 4x squared being greater than y is 0.13 plus 0.25, which of course agrees with the answer we obtained of 0.38. In question 6, we've got two economics students. They are studying some data relating to unemployment X% and the increase in wages Y%. We've got the line of best fit calculated here and some summary statistics. And we need to show that SYY turns out to be this number here. Well, let's recall that SYY is simply sigma y squared minus sigma y all squared over n. So in our case, SYY is going to be 42.63 minus the 23.7 all squared divided by 16, which is the number of observations, which gives me exactly 7.524375 as required. In part B, I need to find SXX, and I will start by reminding ourselves that the average of y, the mean of y, is simply a plus bx bar, where a is the 3.684 and b is the gradient of the line of best fit, the negative 0.3242. This will help me find x bar, because for y bar I know it's 23.7 over 16, which is the sum of the y's over the number of observations. This is equal to 3.684 minus 0.3242x bar, which leads to 0.3242x bar being equal to 2.2075. I will divide to isolate x bar. We get x bar to be 6.7944 ... Well, we know that x bar is the sum of the x divided by n, which means that the sum of the x is simply going to be the mean of 6.7944 ... times the number of observations, which was 16, and this leads to a value of 108.710 ... Well, SXX is going to be the sigma x squared, which is 756.81, minus the sum of the x all squared divided by the number of observations, which is 16. This gives an answer of 18.184 ... which correct to three significant figures turns out to be 18.2. In part C, we need to find the product moment correlation coefficient between x and y. So R is given by SXY over root of SXX SYY. Remember, we've got the number for SXX and SYY, and we still need to figure out SXY. Well, the gradient of the line of best fit, the negative 0.3242, is found by doing SXY over SXX. So we can simply write that minus 0.3242 is equal to SXY over SXX. We have found SXX just before in part B, so minus 0.3242 is SXY over the 18.184 ... I will cross multiply to get minus 5.895 ... is SXY, and I can go in the formula for the product moment correlation coefficient. This will be found by doing minus 5.895 ... over the square root of 18.184 ... times the 7.524375. I'm maintaining full accuracy throughout, and I get an answer of minus 0.504. In part D, we've got a claim that when unemployment is 2%, wages increase at over 3%, and we need to explain how we have arrived at this conclusion. Well, I will simply substitute x is 2 into my line of best fit. Remember, x is the unemployment, y is the increase in wages. So when x is 2, y is 3.684 minus 0.3242 times 2. This gives an answer of 3.0356, which is greater than 3, hence justifying the conclusion. In part E, we're given a formula to find the range of values for x, and we need to use this formula to find estimates for the minimum value and the maximum value. So I will start by reminding ourselves that the standard deviation is given by the square root of SXX over n. So in our case, the standard deviation for x is going to be the square root of 18.184 over 16. So if I plug this on the calculator, I get 1.066 ... We have found that x bar is 6.7944 ... So the lower limit will be x bar minus 3 sigma, which is 6.7944 minus 3 times 1.066 ... which gives an answer of 3.596. Whereas for the upper limit, it's going to be x bar plus 3 sigma, so 6.7944 plus the 3 times the 1.066 dot dot dot, and this gives an answer of 9.992 dot dot dot. And therefore we conclude that the minimum is 3.60 and the maximum is 9.99. In F, we are asked to comment giving a reason on the reliability of the claim given, which was saying that for unemployment being at 2%, wages will increase at over 3%. Well, if you notice, we have found the upper and lower bounds to be 3.60 and 9.99. These are the limits for the range of values of X. And we can see that when X is 2, when the unemployment is 2, we are below the minimum. So we are outside the range, and therefore the claim is not reliable. Then Andy suggests that we use the same regression line to estimate unemployment when wages are increasing at 2%. Well, this given regression line can be used to estimate Y when we know X. X is the independent, the explanatory variable. This is the unemployment in this case. And Y is the dependent or response variable. And we always use the independent to predict, to forecast the dependent and not the other way around. Therefore, we conclude that the suggestion is not valid because the increase in wages is the dependent or response variable, and this cannot be used to predict unemployment.